Okay, so today we are going to talk about, and we're going to introduce a new topic completely. It is rational functions. And so it's going to be a super short video. It's just an introductory video talking about what is it, and we're going to talk about domain. I know you guys all missed talking about domain. Okay, so what is a rational expression or a rational function? Expression just means that it's not an equation. It's just doesn't equal anything, right? So what is a rational expression? Well, we've learned and we've spoken about what rational means in the past, right? So rational, the root word of the word rational is what? Ratio. And what is a ratio? It is a fraction, right? So ratio equals fraction. And we've spoken about rational numbers. Is anything that can be written as P over Q, right? As a fraction. So a rational number is like 1/2, 2/3, or like 0.25 because it can be written as 1/4. Or any whole number, right? Because it's 2 over 1. So these are rational numbers. So a rational expression is just that. Okay, so a rational number is anything that can be written as a quotient of two integers. Now, a rational expression is a quotient of two polynomials. So what that means, excuse me, is that polynomial we defined a while back. A polynomial is an expression that consists of a sum of terms containing integers and powers, right? So like that is a polynomial, and we went through nth degree polynomials. We're not going to go over polynomials again, but it's important that we know that it is a quotient of two polynomials, where a polynomial has coefficients and variables. So what a polynomial also has is it has positive, this is key, it has positive exponents. Right? So for example, let's look at examples of rational expressions, and then I'll talk about non-examples. So fraction and numerator, it is a fraction whose numerator and denominator are polynomials. These are examples. 1 over x. 1 is a polynomial. It is just a constant. So technically, x over 1 would also be a rational function, but it is also linear, right? So some rational functions are classified as different things. So 1 over x plus 5, polynomial. X squared minus 4x plus 4, polynomial, right? Polynomial. This is a polynomial in what form? It is a polynomial in factored form, right? If I expanded this out, right? If I did this and then I FOILed it out, it would be still a polynomial. And then this is just a linear polynomial. So yes, these are a quotient of polynomials. Notice that the numerator can be a constant and that the polynomials can be of varying degrees and in multiple forms. So also, let's talk about non-examples. I'll write it here. Non-examples. So what would a non-example be? The square root of x over x squared. Non-example, because the square root of x is not, excuse me, is not a polynomial. Another non-example would be x squared plus 3x minus 5 over x to the negative 4 plus 8. Negative exponent, not a polynomial. This is the same thing as saying, we could technically rearrange it and get it to be a rational function, but in this form, it is not a rational function. Another non-example would be 2x over 0. Why is this a non-example? Because, and we didn't put it up here, but a rational function is written as, so y equals p of x over q of x, right? P over q, where they're polynomials. where q of x cannot equal 0. This right here is key. And that brings us to our domain, right? So we spoke about a red flag, right? One of the red flags that we had for domain is that our denominator cannot equal 0. And so the domain of any expression, this is just defining domain in general. So domain of any expression is the set of all possible input values, which is generally x, but not always. In the case of rational expressions, we can input any value except for those that make the denominator 0. So except for those that make the denominator 0, since division by 0 is undefined, right? In other words, the domain of a rational expression includes all real numbers except for those that make the denominator 0. So the way that we've written it in the past is all real numbers except x cannot equal blah, 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 right? So here's an example. Find the domain of this function. Now this is in factored form, right? So the domain of this is going to be all real numbers, but x cannot equal what values are going to make my denominator 0? Well, if I do the t-chart and I set this equal to 0, I get x minus 3 equals 0, so x equals 3, and x equals negative 4. So x cannot equal 3 or negative 4. This is my domain. Is there another example? No. I'll do one more. What is the domain of x squared plus 3x over plus 2 over x squared plus x, right? So what you would have to do is you'd have to factor this out, right? And by factoring this, you would have to find the GCF. So basically, I just have to set my denominator not equal to 0 because it can't equal 0. So I'm going to factor this x out. So I get x and x plus 1 can't equal 0. So x can't equal, if this is set equal to 0, it's 0. And if this is set equal to 0, it's negative 1. So 0 and negative 1. So it's all real numbers, but x cannot equal 0 or negative 1. Because these two values are the two values that will make my denominator equal to 0, thus making it undefined.